Hey everyone, welcome back to Take You Forward. So today we will be solving the famous problem edit distance, and this comes under the category of lead code hard. And yeah, we are continuing with DP on string. So this is a problem similar to string matching. So what is the problem like? What does the problem states? You're given a string s1, you're given a string s2, okay, and there are three different operations given to you. One is something like you can take any word, any character, and insert anywhere in string s1. Okay. Next is remove, which means deletion. You can take any character and you can remove from s1. The third is replace, where you say, okay, pick up any character in string s1 and replace with any given character. And you're given these three operations. You're allowed to do these three operations. You have to tell me what are the minimum number of steps in which you can convert this given string s1 into this given string s2. That is what you just need to tell me. And if you're able to tell me that, that is what the question states, edit distance, which states minimum operations by using these three functions in order to convert the string s1 to string s2. In the previous videos, we have done a problem in order to convert s1 to s2 using these two functions, which was insert and delete. But now in this question, I add one more, replace, and that makes the question a bit harder than the previous one. So for an example, let's understand the question. You're given this horse and you want to convert this into this ROS. What is the minimum number of operations? So before finding out the minimum number of operations, let's understand, is it always possible? The answer to that is definitely. Like if you're asking me, is it always possible? The answer is very simple. Yes. How? Delete, 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 delete. Perform the number of deletions. Empty string. Use insert ROS and you convert s1 to s2. So delete all, insert the string s2. So possible at maximum n plus n steps, rather, not big of n plus m steps is the max that you will take by deleting everything and then by inserting. Okay, so let's find the minimal one. So what I will do is I will go across and say, okay, the first operation that I will do is I will replace h with r, which makes it RORSE. This is what the string is. So the next operation will be, I will say, let's remove R, which makes it, that means this R is what I'm saying, which makes it ROSE. Next operation I'll say is remove E, which makes it ROS. And this is nothing but the string S2. How many operations did I need? I needed 3 operations. You can try out all other ways and you'll not find any different combination where you can get into lesser number of operations. So 3 operations required. Did we use insert? No, we were done with replace and 2 removal operations, and we are able to convert this into this. Okay, so let's take one more example, intention and execution. Okay, so the first thing that I will do is I'll say, okay, let's remove E, which makes it inention. Okay, which makes it inention. I said let's remove this particular T, so I removed it, which makes it inention. Next I'll say, hey, can you please replace I with E? I'm saying replace this I with E. I N E N, inention. Done. Next I'll say let's replace N with X. This N with X. Remember, whenever I say replace one N, you can just replace one N. This becomes EXEN, extension. Okay. Next I will say replace N with C, which makes it EXCTION. I said please replace this N with C. Perfect. Next, I will say, can you please insert U? Where? Here. This becomes EXCUTION. Thereby, this is the string S2. How many operations? Four operations is what you required. Four operations is what you required. And this is the minimal set of, or rather five, my bad, five. So these are the minimal set of operations that you will require in order to convert this S1 into this particular S2. And you have to tell me this particular, like you have to solve this question only. So how do you solve this problem? You can say we can go across the string matching path. Yeah, we know that's recursion, which is the string matching path, where we recursively try to match everything. So how do you do this? Let's take this example of ROS and HORSC. Okay, so this is the example that I have taken. So what you try to do is you say, okay, this is E and this is S. So they're not matching. So if they're not matching, how can I match this S with E? One thing that I can think of is I'll just take it off. Yeah, I'll say I don't require this. Hey, listen, let's delete it. So if I delete it, that's fine. Then we will try to match HORS with ROS. So if I just tend to delete it, it's going to be off, right? And then we will be like, okay, this S matches with this S. Then I'll be like, fine, if this S matches with this S, we are pretty much done with first S. Next, I'll be like, okay, this is an S, this is an R, and this is an O. They're not matching. So I can be like, hey, what can I do? I'll be like, hey, listen, let's delete it. So I'll try to delete it. So I'll be like, okay, let's omit this. Perfect. Next, I'll be like, okay, this O matches with this O. So I'll be like, perfect, I got the second match. Next, I can be like, this is an H, this is an R. I'll be like, okay, I need to make this S as an H as an R. Let's replace it. So just replace it. That's it. So I did match SOO, and since I'm replacing, this is also matched. Since I'm replacing, because if you're trying to replace, you'll try to replace it with R only so that it gets matched. So this is matched. So I'm getting an intuition that I have to do a kind of string matching where I take character, like one character from the string S2, another character from string S1, and then try to compare them. If they're matching, it's well and good. If they're not matching, then I have a lot of options. So if they're not matching, what options do you have on your brain? Let's ask it to yourself. If they are not matching, because if they're matching, it's fine. Like for an example, we had a match with O and O. It was fine. If they're not matching, what operations you can? You know, the operation that you can do is you can say I will do an insert of the same character. That's what I can think of. I'll try to do an insert of the same character. How? I'll tell that afterwards. If they're not matching. Or I can say that, okay, I'll delete and try to match it on the back. Delete and try finding somewhere else. Or I'll be like, I'll try to replace and match. Similar to what we did here. This was not matching, so I tried to replace and they got matched. So I kind of I can insert the same character. I can delete and find in the string, or I can replace and match. So these are the three operations that I can think during string matching, right? So I know I have to try all possible ways because I can either insert, I can either delete, I can either replace and match. I can do a lot of stuffs. So if I'm trying to do all possible stuffs, I know among all these ways, I need to figure out what's the best. And that basically takes me to the place where I say, try always. And whenever it comes as try always, you know what comes up? Recursion is the first thing that comes up. I'm going to try every way. I'm going to go across this. And if it states minimum possible operations, out of all these operations, whichever gives you the minimal, you just take it, right? So I'll be like, okay, try all possible ways. That's recursion. How do you write recursion? Because the first step is how to write recursion. So let's actually go back and try to write this recursion stuff. How to write recurrence, correct? So the question is Very simple how to write recurrence. I can say there are two strings. So I'll try to express in terms of, as usual, our rules. In string matching is I represents the first string, J represents the second string. Explore all paths of matching. Explore all paths of matching or possibilities of matching. What is the question stating? Give me the minimum number of operations. So I'll be like, return the minimal of all paths. Return the minimal of all paths. Again, makes sense. Fourth is definitely the base case. Fourth is definitely the base case. There is no other thing that I can at least think of. So let's try to write the recurrence now. So I can be like, okay, I'll start with f of ij, and as usual, we'll write the base case afterwards. But we need to understand what does f of ij signify. So assuming it was horse and ROS, assume I is here, j is here, which means f of n minus 1 and m minus 1. What does this signify? This signifies find me the minimum operations to convert string s1, which is from 0 to I, to string s2, which is from 0 to j. That is what it signifies. From 0 to I, convert this into 0 to j. That's what it signifies. If I would have been here, convert HO to ROS. Got it? If j would have been here, I would have been here, convert HOR to RO. So that is what f of ij signifies. So what cases will be there? I know whenever we are doing string matching, there are always two possible set of cases. One is if they match, the other one is if they do not match. So we'll write the base case afterwards. We know one thing, if they end up matching, yes, if they end up matching, it's a very common thing. If they are ending up matching, do we need to do anything else? Do we need to perform an operation to try to match them? The answer to that is no, Striver. For an example, if you are standing at this O and you're standing at this O, dude, they are matching. Why do you want to do an insert? Why do you want to do a delete? Why do you want to do a replace? There's absolutely no need of doing anything. So what you do is you say, hey, listen, they're matching. So let's shrink the string and try to find the answer in the shrinked string. So I'll be like, okay. So if they're matching, am I actually applying any number of steps? The answer to that is no, Striver. We are not applying. So I'll be like, if they're matching, hey, listen, I'm not applying any set of steps. And my string also reduces to this. And now I'll try to find the answer. How many steps are in this reduced string? Because I and j have matched. So I'll try to see how many steps does this string take to convert into the string. That's what I'm doing. Perfect. What if they don't match? If this if is not executed, then it will come over here, which is the else condition. What then? Then I know one thing for sure. Let's come back. If this E is not matching with S, what is the first thing that I can do? Let's think. I can be like, okay, fine, listen. I can write an S, which is insert operation. Yeah, I can just insert an S, and I said this S is matching with this S. Right? And I can say let me just write it. I'll write this S and I'll move this J. And now I'll say this S matched with this S. But I'll keep the I here because hypothetically, I've tried to place this S right ahead of I. So that next I can compare this E and O. I hope that makes sense. So in an insertion, since hypothetically you're inserting an S right there, so the I is still at E because hypothetically you have entered an S. So I stays where it is because this S and this S has matched. But you do an insert operation which takes this S and S similar and the J reduces. So I can say the replace operation is going to be very straightforward. I stays where it is and the J reduces by 1 because you have hypothetically inserted S, so they have matched. So I is still, because mere aage, someone got inserted right ahead of me. Why will I bother to move? I'll stay where it is. This S got matched. So j will get reduced. So that is how you can do an insert operation. Perfect. So if you're doing this insert operation, that's one step. That's one step. Perfect. Can I do something else? Let's go back. Let's go back and see if I can do something else. Let's erase this. Can I do something else? Okay. What operations do I have? I have a delete operation, right? I'll say, hey, let's delete this and let's take this and try to match this S with this S. I'll be like, let's delete this. Let's take this I here and now try to match this S with S. I'll try to delete it. So if I delete it, I'm saying, go. So I reduces. I will reduce. I'll be like, yeah, makes sense. So if I'm trying to delete it, can I say, only I reduces, and I'm again taking one step. I will reduce, and does the J reduce? No. You deleted, but you're still looking for this S. You deleted, but you're still looking for this S, which will get matched at the next step. Thereby, I only reduces, the J stays where it is. Perfect. What about the other one? So again, we will just go back and try to just write it again back. Yeah, perfect. Where was I? I was here, right? We have a E, we have a S. What is the other thing? We have done insert, we have done the delete as well. The other thing is definitely replace, because that's the other operation remaining. If you're replacing, what is like, will it make sense if you replace it with A? No. Why will you replace it with A? You're not a fool. Are you a fool? No. So you'll be like, what will I replace that with? I'll be like, okay, let's replace this with S so that this S now matches with this S. And now I can look for in the remaining portion of the string, because in order to replace, I will try to match these guys. So replace will be done in that way. And after they are matched, I reduce both the strings. So I'll be like, okay, if you're trying to match, it's still replace operation is still 1. And you reduce both the strings. Perfect. You reduce both the strings. So these are the 3 operations that you will encounter if they are not matching. And by doing these 3 operations, you will somehow or the other try to match it. And after that, you have to take the minimal of all of these 3. And that's what you do. And that's how you can write all possibilities. Wow. Last thing. Base case. What can be the base cases? Try to think. Generally, the base case is when it's over. What did I say? Base cases when it's over. That's when you think of base cases. Correct? So when it's over, what does that signify? You were comparing someone got exhausted. Someone would have got exhausted, right? Let's analyze what happens if string 1 gets exhausted. Let's analyze the other way when string 2 gets exhausted. Okay, so there can be 2 ways. Because I know one thing for sure, if I and J are somewhere over here, somewhere on a character, we can still do operations. But what if they don't have any characters? For an example, we were at something like horse, right? Let's take a word as HORSE rather. And you came over here, which is the -1th index. This is where the I is, right? That is when I say string 1 gets exhausted, when I is over here. And you still are having a rows. And assume you're over here, which is J. Correct? So what is J? J is at the 0 and 1 index. So if you're looking to make RO and you have exhausted, like this string doesn't exist, you have exhausted. How many operations will you require to make RO? Obviously 2 operations. Because if you don't insert RO, what am I saying? Let's understand what does this signify. F of -1 and 1, because this is 1. This is where the J is. That means minimum operations to convert a empty string because -1 means you don't have any string. Convert an empty string to a string from 0 to 1, which is nothing but RO. What are the minimum operations you'll take to convert an empty string to RO? Obviously, you'll require two insert operations. Can I say if string S1 gets exhausted, you end up returning J plus 1? Because if J is standing at the index 1, it will take two insert steps. So I can say you can return J plus 1. That's how you have to analyze. Perfect, guys. So if this string gets exhausted, you have to return J plus 1. What about the other thing when S2 gets exhausted? Let's write it. If S2 gets exhausted, whatever you can call it. So imagine S1 is horse and probably you're standing somewhere over here, which is 0, 1, second index. And S2 was, like you're standing at -1, there was ROS, which is 0, 1, 2. This is where J is. So what does this signifies? F of 2, -1. What does this signifies? Operations, minimum operations to convert HOR to an empty string. How many operations? Oh, come on, guys, you can't tell me. Obviously, it'll perform 3 delete operations, which means I plus 1 because you're standing at 2, so 3 operations. So can I say, if it happens the other way, which is if this gets exhausted, you will say it'll require I plus 1 operations. Perfect. That's how you write the base cases. And that's how you do this edit distance. Wow. Okay. So again, we are doing recursion. So you're trying all possible ways. So obviously the time complexity will be exponential. Because there are 3 states where you're calling, so it will go up to 3 to the power n into 3 to the power m. So we are not discussing that because it is a lot complicated. What is space complexity? Auxiliary stack space. Again, n plus m can go as, that can be the auxiliary stack space. You have to see for overlapping subproblems. So if you try to draw the recursion tree where you're comparing, you will see overlapping subproblems. Okay. Try drawing the recursion tree by yourself. You will see there are portions where there are overlapping subproblems. So if there is an overlapping subproblems, what do? You tend to memorize. Is there even a doubt? Yeah, you tend to memorize. Just go across and try to memorize this. So if you're trying to memorize changing parameters, I and j, what's the maximum value of I? N, what's the maximum value of j? M, so n cross m dp is what you end up taking up. So in memorization, you know what to do. Just a couple of steps. Just make sure you, before returning, write it. And before coming over here, just make a check. And if you're able to do this, I am successfully able to convert this into a time complexity of number of states into a space complexity of the DP array plus an auxiliary stack space. Amazing. Wow. That's what the memoization time complexity will be. So let's quickly code this up. So you're given a string S1 and string S2. Let's find the size super quickly. str1.size. Let's find the size for m as well. str2.size. Perfect. And time to write the function. So int f, int I, int j, string S1. You can call it as S1. You can call it as string S2. Perfect. Now I know the base case is very simple. If one string is exhausted, it's gonna take these many steps. If the other string, if the other string is exhausted, it's going to take another I plus 1 steps. If they are matching, which is this equal to this, you know, it's going to take 0 steps. So 0 plus f of I minus 1 because they're matching. So let's not do anything. If they're not matching, then I know it's going to take 1 plus minimum of, there can be 3 operations, I minus 1 j, or minimum of f of I comma j minus 1 and comma f of I comma, this is the replace. So that's what it will be. Let's quickly check. Yeah, And over here you can say return the function of n-1 and m-1 and str1 and str2. Yeah, that's what you can call it. So let's quickly run this off. This will be s1, s2. Okay, this will be s1, s2. Again, this will be s1, s2. Perfect. It does run fine. Let's quickly convert this into a DP. So vector of vector int dpn vector int and m -1. You can definitely pass it over here, which is vector, rather dp. Just try to copy paste this over here. Okay, so pass it by reference. So make sure everything is passed by reference, because I don't want everything to create a new copy, because that's going to take a lot of space. dp rdp, and just make sure before returning dp of ij, perfect, before returning dp of ij, perfect, and right here before entering dp of ij is not equal to -1, so return of dp of ij, perfect. Once I've done this, I think it should be fine. Let's quickly run this off. Yeah, it does run. Let's submit this. It is submitted. So make sure you carry by reference. Okay, so we definitely know that in recursion there is an auxiliary stack space we generally tend to use. So can we avoid the auxiliary stack space? Obviously, and you know how can we do this? We can say we will convert this into a tabulation. What are the rules? Very simple. I've already told you the rules. Base case. Next. Yeah, write it in the opposite fashion. I and j, the changing parameters. Next, copy the recurrence. So what are the base cases? Let's analyze. Again, in all the string from LCS to the previous question, whenever there is something like this, you know, the states that will come will be like for I it can be -1, or for j it can be -1, right? So there can be a negative, and I don't usually want negative. So what we do is, in order to avoid negative, we just do a +1 to everything. Like initially, where did I go? Yeah, initially we started with n-1. So we will do a +1 and we will say n and m. Yeah, that's what we will do initially. Okay. And everywhere, yes, everywhere, we will try to do a +1. So basically this was less than 0. Now -1 means 0. So over here this will be equal to. Over here there will be equal to. This will go as j, this will go as I, because now you're using 1 based indexing. Now I equal to 3 is actually meaning second index. So second index will return 3 steps only. So you just need to return j or I. Perfect. Just in over here you have to just make sure you do a comparison of I-1 and j-1. That's it. Just a slight change. And that should be converting this into a 1 based indexing. So without actually waiting, let's go back and do this in the code so that we don't have an issue afterwards. So this is going to be equal to, this is going to be this is going to be equal to, this is going to be I +1, and yeah, obviously this is going to be I-1, j-1, and just make sure this is m+1 because the states have increased by +1. So what I did was I just converted them into a 1 based indexing so that we don't have any negative indexes involved. So a slight change will do it. Okay. Now, since I've done the slight change, let's write down the base cases that we took. What are the base cases? As of now, one of the base cases is if the string s1 is exhausted, you try to return j steps, right? So for any I equal to 0, that means f of 0 comma j can be anything. J can be anything. So you will be like, okay, j can be anything. Perfect. So I'll be like, j can be anything from 0 to m. So dp of 0 on any j, please put on j. You see, on any I equal to 0, on any j, you're putting j. So just make sure you put it across. Okay. That's the base case one. What about the other base case? it states for any j equal to 0. Yes, for any j equal to 0, please return I. For any j equal to 0, please return I. So you will be like, okay, fine. For I equal to 0 till n, because that is what I will be, I comma 0, because you are saying for any j equal to 0, which means I can be anything, equal to I. That's it. This is going to be the base case 2. Perfect. I've written both the base cases. Now what's the other thing that we are dealing with? This and this. What is tabulation? It's bottom up. Bottom up. So you were doing the top down via this. Base cases have been computed. So you go from 1 till n, 1 till m, and you copy paste the recurrence. So what are you waiting for? Let's write the tabulation. So what you can do is you can just put a 0 over here. That's perfect. And just make sure for any I equal to 0 till n, just make sure any dp of I of j, which is 0, will be I. Perfect. And the other one will be for any j equal to 0, j lesser than equal to m, j plus plus, dp of any, like any of I, which is 0, and any of j will be j. Perfect. That's what the base cases will be. And the other two will be I equal to 1 till n and I plus plus. For int j equal to 1, j lesser than equal to m, and j plus plus. And what I can do is I can just copy paste the recurrence. So please copy paste the recurrence. I'll go over here and I'll try to copy paste. Perfect. And instead of this, please write else. Why? Because if it matches, you run this. Otherwise, you run this. Over here, else was not required, because if this executes, this will never execute. But over here, you have to give an else. That's what you'll write. And over here, just make sure you will write dp of I minus 1, j minus 1. So dp of I minus 1 and j minus 1 is what you will write. Perfect. And you can just remove the return statement. That's what this will be. And over here, you can simply say dp of I minus 1, j, dp of I minus 1, j, dp of I j minus 1. So please write dp of I and j minus 1. And you can simply write dp of I minus 1 and j minus 1. Perfect. And that is what you will be returning, dp of n and m, because that is what the call was made for. So if you write this and try to run this, this will be running absolutely fine. Whenever I say absolutely fine, it ends up not being absolutely fine. Anyways, what you can just do it, you can just convert this into str1 and str2. It does run. Let's quickly submit this and see if this is working fine. It is. We are getting a correct answer. So can we space optimize? We're using an n cross m matrix. Can we space optimize this? Let's quickly check. Okay, there's an I minus 1. There's an I minus 1. Okay. So something for sure is we can definitely space optimize, because there is a I minus 1 involved. So what I'll do is I can say that, hey, listen, what does this actually mean? Like, what do I actually require? I just require one previous guy, and then I'll use that previous to fill this current. Correct. Okay. So I just require to fill the previous guy. And what does this mean? This means on any row, let's understand, on any row, I is row, the first column has to have I, the row number rather. The 0th row will have 0. The first row will have first. The second row will have second. The third row will have third. That is what it signifies, right? So the first row on the first place will have 0. So we have got this base case covered, because we are just requiring the first row. What does this signify? This signifies on the 0th row, yes, on the 0th row, which is the first row which I'm filling, at every column, you will put 0, 1, 2, 3. This is what it signifies, right? So just put this. So you'll be like, okay, I just compute the previous, I'll put it, and this is not required anymore. So I'll just go across and try to declare this as vector of int of previous of m plus 1 comma 0, because I just require rows. cur of m plus 1 comma 0. Perfect. Next, instead of dp of I minus 1, I'll say previous. Instead of dp of I, I'll say cur. Amazing. Instead of dp of I minus 1, I'll say previous. Instead of dp of I will say definitely cur. Instead of dp of I minus 1, I'll definitely say previous. Instead of dp of I, I'll say cur. And I'll write previous equal to cur. And over here, I'll try to return previous. This has been taught in all the DP lectures. So if you haven't seen it, please go back and watch the previous lectures. Okay, now I try to run it. Okay, we're getting a wrong answer. Why is that? Let's quickly have a check. Okay, so why did we get a wrong answer? So if you remember, there was a base case for any j equal to 0, which means for any row, it can be this row, it can be this row, it can be this row. For any row, the zeroth guy was, for the zeroth row, it was 0. For the first row, it was first. For the second row, it was second, right? So for every time you're using cur, you have to update its zeroth guy, because every time cur will have some values in the zeroth column. So make sure every time you're using cur, it will always have I. It will always have I. So that's what you will do. And you'll say this is running fine. So once you've done this, I hope this is clear. Just in case this is not clear, try to see this, you'll get an idea. Because if at any j equal to 0, it will always be I. So at any current row, the first guy will be I. Right? So this is how you can definitely space optimize this portion. Can you space optimize this into an 1D1? The answer to that is no, because you're dependent on the previous state of the current as well as the previous state of the previous. So you need to store both the rows, the previous and the current. So you cannot space optimize this further, like beyond 2 1D arrays. So this is the maximum that you can do. So guys, I hope you have understood this entire edit distance, right from the recursion to the memoization to the tabulation and to the wonderful space optimization. So just in case you did, please make sure you like this video, and if you're new to this channel, please do consider subscribing to us. And yeah, let's continue our tradition. Please make sure you write in the comment section video, how was the video. So yeah, with this, let's wrap up this video and meet you in the next one. Till then, bye bye, take care.
Whenever your heart is broken.